All right, this is one of the fun ones we did today in class. So we're going to actually look at this figure, number 6, and we're going to determine I can speak English, determine what number 6 represents. So I've already plotted the 4 points. You're given A, B, C, and D. And I want to know what kind of quadrilateral this is. Now, I'm pretty talented, so I can connect dots. Don't be jealous. So I'm going to connect the dots here. And I have what appears to be a trapezoid, but I can't just say it's a trapezoid because it looks that way. I have to actually prove it. So we're going to find the lengths of the sides, which means length is another word for distance. So what I'm going to do is I'm going to use the distance formula. So remember, the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So I'm going to find the distances. So let's do the first distance. The first one is AB. So I'm going to find this side right here. All right, so for the distance for AB, okay. The distance for AB, what are my two x coordinates for A and B? -2 and -2. So I have -2 minus -2 squared. My two y coordinates are -2 and +4, so I have -2 minus +4. And if I work that out, that comes out to, that's plus a positive, that's going to go to 0. So 0 squared plus -2 minus 4 gives you what? -6, and when you square that, you get 36. So it's the square root of 36, which is 6. So AB has a length of 6. Let's look at BC. BC, now I'm looking at B and C. And again, I always write the formula first and then plug in. So BC, what are my two x's for B and C? -2 and 4. -2, +4, and 4 and 8. 4 and 8. -2 minus 4 gives you -6, which is what we're going to be squaring, and 4 minus 8 gives you -4, which is what we're going to be squaring. So basically I have 36 plus 16, which is 52. So I have the square root of 52. That's the length of BC. Okay? So you can see so far we know at least it's not a rhombus, right? Because a rhombus would be all 4 sides are the same length. Well, I've already got 2 that are different. So let's do CD. That's this guy right here. CD, I'm going to do my distance formula. So CD, I have 4 minus 4. And then I have 8 and -6. 8 minus -6. Minus a negative changes to plus a positive. 4 minus 4 is going to go to what? 0. So I have 8 plus 6, which is 14. So I have 14 squared, which is 196. And the square root of 196 is just 14. So now I've got 3 sides that are different. So now I've shown that it cannot be a parallelogram, because if it were a parallelogram, at least the 2 opposite sides, one pair, or both pairs of opposite sides would be congruent. I've got 3 completely different lengths here. I don't have anything that matches so far, and I've got one side left. So it's probably not going to be a parallelogram. We can verify that though. So let's look at AD. If I'm looking at AD, I'm going to take the square root. AD, I have -2 and 4. So I have -2 minus 4. And I have -2 and -6. So I have -2 minus -6. -2 minus 4 gives me -6 squared. Minus a -6 goes to plus a positive, so that's 4 squared. So I'm going to end up with 36 plus 16, which is the square root of 52. Okay, so what have I established? I know that BC, which is square root of 52, and AD, which is square root of 52, are congruent. So I'm going to mark them congruent. Okay? It can't be a parallelogram because BA and CD would have had to have been congruent too. So it's not a parallelogram. Let's see if it's trapezoid. Okay, so now let's go down to slopes. If you remember for slope is rise over run, which we don't like to use that much. It's the difference in x over the y and over the difference in x, change in y over change in x, vertical change or over horizontal change. So I'm going to find the slope of all these. So let's find the slope of AB. So I've got AB. So I'm going to find the slope of this guy here.
Like this?
The slope of this guy, AB. So the 2 points A and B. Remember, y's go on top. So for AB, what's on top? 4 and -2. So I've got 4 minus -2 on top. And on the bottom is -2 and -2. So I've got -2 minus -2. That becomes positive. So I've got, and that's a positive. So I end up with 6 over 0. Uh-oh. What does that mean? That's an undefined slope. Because you can't divide by 0. And why is it undefined? Look at AB. It's vertical. It's vertical. The slope's undefined. Okay, so now let's look at the slope of BC. The slope of BC, we'll put our slope formula in here. I love writing teeny tiny just to make you squint. Okay, my slope formula here for BC, if I look at B and C up here, I've got 4 and 8 on top, my two y's, B and C, 4 and 8, and -2 and 4 on the bottom. So 4 minus 8 is -4, -2 minus -4 is -6, so I have 2/3 as my slope. 2/3 is my slope, okay? So I'm going to move on. I'm going to do the next one. I'm going to find the slope of CD. Well, let's do the same thing to find the slope of CD. What are my two y's? 8 and -6, so I got 8 minus -6 on top. And my two x's are 4 and 4. So I got 4 minus 4 on the bottom. So I'm going to end up with 14 on top, because that's plus and minus a negative is plus. And I'm going to have 0 on the bottom. What does that mean? That's undefined as well. So those two slopes are undefined, which means since they're both undefined, they're both vertical, which means they are parallel. They're parallel. So the next thing I'm going to do is I'm going to find the slope of AD. And the slope of AD is going to be my last one. So A is -2 and -6 on top. And then -2 and 4 on the bottom. So that becomes plus a positive. So I get +4 on top and -6 on the bottom. So I get -2 over 3. Is that the same as this one? No. So I do have one pair of parallel sides. These are both undefined, so they're both parallel. What do we call a four-sided figure with only one pair of parallel sides? That is a trapezoid. However, I can go a step further. What did I establish about this trapezoid with the distances? That the two non-parallel sides, or legs, are congruent. Therefore, it's not just a trapezoid. It's an isosceles trapezoid. That's an isosceles trapezoid. So for my reasoning down here, to justify it, my isosceles trapezoid is, how do I know it's a trapezoid? Well, it has one pair of parallel sides and one pair of non-parallel sides. Stop, Kaylin. Get out of here. So one pair of parallel sides and one pair of non. How do I know it's isosceles? Where did I get the isosceles portion? Well, it's isosceles because both legs, which are the non-parallel sides,
look at him,
are congruent. So that's how you can determine if it's a trapezoid, isosceles trapezoid. It can be a trapezoid and you can have the same slopes, but not have the legs be the same, so it's just a generic trapezoid. But in this case, the two legs are both square root of 52. They're identical. And I've got an audience now.